there, students! Welcome back to another exciting lesson. Today, I'm diving into the fascinating world of energy stores. This topic is important in helping us develop a language for describing changes in energy in everyday life, such as when we eat food, exercise, cycle, walk, heat a house, or fuel cars. Understanding energy empowers us to make informed decisions about energy usage, conservation, and sustainable practices for a better future. First up, let's talk about the law of conservation of energy. This fundamental principle is the backbone of all energy-related concepts. This law states that energy cannot be created or destroyed, only transferred between stores. It's like a universal rule that energy must follow. Imagine it like this: energy is always on the move, changing stores but never disappearing. It's like a shapeshifter, constantly transferring but always present. So what are these energy stores? Let's break them down one by one. First, we have the chemical energy store. This one's emptied during chemical reactions when energy is transferred to the surroundings. Burning fuel is a classic example. When you light a candle, the chemical energy store in the wax decreases, and the thermal energy store in the air increases. This transfer perfectly demonstrates how chemical energy is shifted into other energy stores. Next, we have the thermal energy store. This store is filled when an object warms up. Picture heating water in a kettle. As it heats, the water's thermal energy store gets filled. The boiling water clearly indicates thermal energy being transferred from the kettle's heating element to the water. The more you heat the water, the more thermal energy it accumulates. Now, onto the kinetic energy store. This store fills up when an object speeds up. Think about a car accelerating on a highway. The faster it goes, the more kinetic energy it has. This energy is what keeps the car moving and allows it to overcome resistance. Then there's the gravitational potential energy store. This store is filled when an object is raised. Imagine climbing a ladder. The higher you go, the more gravitational potential energy you store. It's like building up energy reserves the higher you climb. This energy is stored due to the position of the object in a gravitational field. Last but not least, we've got the elastic potential energy store. This store is filled when a material is stretched or compressed. Take a spring, for example. When you stretch it, you're storing elastic potential energy. This energy decreases when the material returns to its original shape. So, there you have it: chemical, thermal, kinetic, gravitational potential, and elastic energy stores. And remember, according to the law of conservation of energy, these stores are constantly transferring energy between each other. This continuous transfer is what powers everything from the smallest atom to the largest galaxy. Chemical, thermal, kinetic, gravitational potential, and elastic potential energy stores are all around us in everything we do. And remember, these stores are constantly transferring energy between each other, maintaining the balance of energy in a closed system. To wrap up, think about this. Every time you eat, move, or even exist, you're part of this incredible energy transfer system. Pretty cool, right? Thanks for tuning in. Keep exploring, keep questioning, and keep learning. See you next time. Stay curious and stay energized.